Have you ever wondered why some roads are steeper than others, or why the roof of a house is inclined at a certain angle? These everyday observations are not random. They're dictated by a fundamental mathematical concept, the slope of a straight line. It's everywhere around us, from the gradient of a hill to the incline of a staircase. It's an invisible hand, shaping our world in ways we often overlook. It all comes down to the slope of a straight line, a fundamental concept in mathematics. So what exactly is this slope? In simple terms, it's a measure of how steep a line is. Imagine standing on a hillside. The slope is essentially how steep that hill is. If you're walking up a steep hill, you're dealing with a high slope. If it's more of a gentle incline, then the slope is lower. In the world of mathematics, this concept is no different. The slope of a line is calculated as the ratio of vertical change to horizontal change between any 2 points on that line. This is often referred to as rise over run. If you're wondering about the term rise, it denotes the vertical distance, or how much you move up or down. Run, on the other hand, represents the horizontal distance, or how much you move left or right. To calculate the slope, you subtract the y-coordinates and divide by the difference of the x-coordinates of 2 points. It's like saying, for every step I take forward, how much do I go up or down? Now, here's something interesting. A positive slope indicates an upward direction, while a negative slope indicates a downward direction. This is quite intuitive, isn't it? If you're climbing up a hill, you're going in a positive direction. If you're descending, you're going in a negative direction. So, the steeper the line, the greater the slope, and vice versa. Why does the slope matter, you ask? Well, the slope of a line has some pretty important implications. Let's delve into it. In the realm of physics, the slope can symbolize speed or acceleration. Imagine a car moving at a constant speed. The slope of its position versus time graph would be a straight line. The steeper the slope, the faster the car is moving. Next, let's look at economics. Here, the slope could represent changes in cost or profit. A steep slope might indicate a rapid increase in costs or a significant jump in profits. Now, consider geography. The slope can illustrate the steepness of a terrain. A high slope might mean a steep mountain, while a low slope could signify a gentle hill. Clearly, the slope is more than just a mathematical concept. It's a tool for understanding the world around us. So, let's quickly recap what we've learned about the slope of a straight line. We've unraveled the concept of slope, understanding it as a measure of steepness or the degree of inclination of a line. We've also learned how to calculate this slope by dividing the change in the vertical distance, or the rise, by the change in the horizontal distance, or the run. Furthermore, we've explored the meaning of slope direction. A positive slope indicates an upward trend, while a negative slope points to a downward trend. And zero, well, that's a flat line with no inclination at all. But the slope isn't just a mathematical concept, it has real-world implications too. It's seen in the steepness of a road, the slant of a rooftop, and even the growth rate of a company. Next time you see a steep road or a slanted rooftop, you'll know it's all about the slope.